Good afternoon, good evening, and good morning to everyone. Thank you for joining us for your workshop. And today's workshop is NCA analysis using R. As you're all aware that this workshop is going to happen on, of course, today. And then we will have the follow-up of this workshop on November 1st. So please mark your calendars and make sure that you are available for that day as well. So today's workshop's host is Project Dontabhaktuni, and it is sponsored by Gilead Sciences, PharmaPro Consulting, and Human Predictions. For those of you who don't know Project Dontabhaktuni, Project Dontabhaktuni is a nonprofit organization created to help you. And our motto is to empower you so you can empower others. We were created about 3 years ago, and we take pride in sharing that in the past 3+ years, we have trained over 2,000 PhD PharmDs from 40 countries. What we offer is workshops, training programs, and mentoring programs to help grow your career. And how can you help us? You can help us by joining hands with us and helping us such that we can reach a broader audience. And definitely another piece that you can do is whatever you learn here, please teach one more person in your life. And that's all we ask. And do step in to become mentors. You may be surprised there are so many people you can touch by what you're doing. So looking forward to joining hands with you and participating in this journey with you. And I am Aruna Dontabhaktuni, founder and CEO of PharmaPro Consulting and founder and scientific director of Project Dontabhaktuni. I am also adjunct professor at University of Pacific, where I teach clinical pharmacology and regulatory affairs. So just to give you an idea, who is with you today? So as I mentioned, we have close to 300 participants joining us from 26 countries. And I also wanted to give you a glimpse of what is the participation level. So we are looking at mostly PhDs or master's participants. We also have PharmDs. And again, looking forward to this journey with you. These were some of our past workshops. If you are interested, please go to our YouTube channel. All the workshops that we have conducted online are available on our YouTube channel. Post this workshop, we can send you the details, and feel free to take those or attend those training programs. And if you have questions, please do reach out and we'd be happy to help you. So moving on and bringing you back to today's workshop, I would like to request Rajan, who's our advisors in the Project Dontabhaktuni, to introduce our today's host of the workshop, Dr. Bill Denny. So handing it over to you, Rajan.
Thanks, Aruna. Good morning, good evening, good afternoon, wherever you are. Dr. Bill Denny, the founder of and CEO of Human Predictions, and has over 12 years of experience in mathematical modeling. Prior to starting Human Predictions, Bill was a director of clinical pharmacology at Pfizer. In this position, he developed pharmacometric tools and models to enhance transparency and understanding of internal development compounds. Prior to Pfizer, Bill worked at Merck in clinical PKPD department. Throughout his time in the pharmaceutical industry,
I think Dr. Rajan's bandwidth is having some issues. So again, my apologies for that. This is what happens when you're working across the world. So without further ado, I would like to request Bill to take over. And again, thank you for making this time, Bill. For some of you who may not know, Bill has been a strong proponent of using open source tools and is a thought leader when it comes to non-compartmental analysis using R. And it's our honor and pleasure to have Bill with us, and you're actually able to participate in a program from the best in the world. Thank you again, Bill.
Thank you very much for the extremely kind introduction. I appreciate the opportunity to be here, and thank Arunya and the entire team who is making this happen. It's a wonderful event to be able to contribute to and project to help move forward. I also loved what you said, Arunya, a few minutes ago. The goal is not just to learn, but also if you're able to take this forward and teach one more person. I think that is a great goal to share for the entire project. And so, without further ado, I'm going to start. I'm going to start with the presentation. And as Arunya mentioned, there will be two main opportunities for Q&A as we're going through. I do intend to try and keep an eye on the chat a bit, and if I see a question pop up repeatedly as I'm going through, I may take a little aside to go into it. But there will be two primary times to ask questions as we're going through. It will be easier given the large number of participants if people are able to type their questions into the chat window. And then one other bit of information is that as you are learning about PKNCA, there are opportunities during the next few weeks to work within your group to learn more and work on some of the hands-on examples. And as you are working beyond that time, there's a lot of information available on the GitHub website for PKNCA so that you can take all of your learning further. So without further ado, today's will be a session on PKNCA. The goal of the session is to help introduce you to PKNCA with the overall, with an introductory focus. It is not necessarily getting into some of the more advanced features of PKNCA, which you can, again, learn about on the PKNCA website and in other training materials that are posted on the website, where these training materials are also posted. So what is PKNCA and how will you start using it? PKNCA is a tool for calculating non-compartmental parameters using R from pharmacokinetic data. You already knew that, or else you wouldn't be here. And it has several different foci in terms of the way that it tries to work. It has a goal to be regulatory ready, and doesn't just have that goal, it achieves it. It has approximately 100% test coverage, which is a computer programming concept where almost every single line of code in the entire PKNCA that's written that runs PKNCA has a test that runs against it to make sure that it's doing what it's intended to do. It has a goal of being reproducible. It uses R in a scriptable way so that you can easily insert it into your own process or develop your own internal methods for using it. And so it doesn't have as much of a point and click interface. There is a graphical interface that was recently released called Ruminate that is not the focus of today's discussion. but the goal here is to also make, like I said, to make it so that you have reproducible work. And if you run it one time on one computer, you can reproduce that anytime on any system. It also has a goal of either giving you the right answer, or if there's uncertainty, it will raise that uncertainty to you either with an error or by giving you information about how the your data may have an issue. As an example, if you can't calculate the half-life because you don't have a sufficient number of time points for half-life calculation after Tmax, then it will, as part of the output, show you that there were too few time points and tell you what subject and when it was, what time points for that subject it was looking at. And I hope you enjoy this discussion and also your future use of PKNCA. I hope you have a whale of a good time. That's a little bit of foreshadowing for later. Well, the goal of this course is not necessarily to teach non-compartmental analysis or the underlying math behind it in detail. The intent is to, there are some terms that will be helpful to just make sure that we're all on the same page in terms of understanding what some of the parameters we'll be talking about for non-compartmental analysis are. And there's a lot more information again on the PKNCA website, and for non-compartmental analysis, it is also available on in many textbooks and other locations around the web. The Cmax is the maximum observed concentration. So simply, if you find the maximum value within your data set, that is Cmax. Tmax is the time at which you observe that maximum concentration. Tlast is the time of the last concentration that's above the limit of quantification. So as you may be aware, when measuring pharmacokinetic data, there is a lower value below which you cannot accurately quantify the concentration. And those values for PKNCA and most other tools are input as 0. And Tlast is the last concentration where the value is above 0. The area under the curve, or AUC, is the integrated area over all times for a subject, and there are many variants of the area under the curve. Some of the important and more common variants are the AUC last, which is the area under the curve measured from time 0, the initial time point, up to the Tlast that we discussed earlier, the last concentration above the limit of quantification. Another very important AUC parameter is the area under the curve during an interval of time, the AUC int. It is the area under the curve from, it can be any time, typically time 0, the time of dosing, up to any later time point. And the AUC int is different than the AUC last in that it will interpolate or extrapolate to get the expected area under the curve. In data sets when you're using nominal times, so the planned time, but maybe not the actual time, that the minute when an actual sample was taken, then the AUC int and the AUC last can often be the same. When using actual time data, you often need to use AUC int to interpolate. Let's say you plan to have a sample at 24 hours, but it was after the dose, but it was taken at 24.5 hours. Then you need to interpolate between that sample before 24 hours and the 24-hour sample. And that's what AUC int does differently. AUC infinity is the area under the curve from the dose through extrapolated out to infinity. And it's often used to estimate the total exposure that a subject will experience with the dose over all time. And it's also used to very commonly to understand things like dose linearity and other parameters that are necessary for many different parts of non-compartmental analysis and generally in drug development. So first we're going to, within the specifics for PKNCA, we're going to talk about the data sets that are needed and how you set up PKNCA. Different tools use data in different ways, and PKNCA tries to mimic the way that data are collected so that it is most straightforward to use your data immediately and directly without, and hopefully needing less data management and other steps along the way. For that, it's some of you may be familiar with the concept of tidy data. There's within R, there's the tidyverse, and the general idea that data sets can be set up where each column is information about an observation, and each row is a separate observation. So, for instance, a data set for PK may have the concentration of a drug and a metabolite, and those would need to be on two different rows to be tidy in the sense that is often used with the CDISC standard, so SDTM or ATOM, and many other data standards in the world. For that, the concentration time data is set up to be similar to the PC domain in the SDTM data sets that you may get from a clinical trial. It can also, to be clear, PKNCA does not require any specific data formatting. It is just set up where you can send in your concentration data, your dosing data, and then get out your NCA results. And it should work with any format, any type of data without any strong requirements on the formatting of the data set itself. You just have to tell it what columns to use. So as I was saying, the concentration time data, similar to the SDTM PC domain in clinical trials, also send data in non-clinical trials, but any way you can collect the concentration time data can be used with PKNCA, and that goes into a PKNCA concentration, PKNCA conc object. Then you have your dose and time data, which is optional for PKNCA, but if you need things like clearance, you do need to provide the dose information. And it is similar to either the EX or EC domain in SDTM data or SEND data. And it uses a PKNCA dose object. You'll notice that for these, I have highlighted the type of object with open and closed parentheses after them. And that is because there is a function that we'll be seeing a little bit later that is how you tell PKNCA about these two, about these data types. Once you have put your concentration and optionally your dose together, you combine them in a step that we'll look at a little in more detail later, which is the PKNCA data object. This would be most similar to your ATOM data sets that may be set up for calculating non-compartmental analysis in clinical trials. But again, it does not require any specific data format. And then finally, to calculate your results, you'll use the pk.nca function. And that would map to, that gives you all of your non-compartmental results across all of the subjects that you've asked for parameters, ask for non-compartmental parameters to be calculated for, and it will, and it looks like the SDTM PP domain. The minimum data that PKNCA requires is the concentration and time data. Graphically, it could look like what you see here on the screen, where you have the concentration was likely dosed at time 0. It's going up through the for the first couple of hours, and then it is declining. After you give it the concentration time data as a data frame in R, you have to tell it what columns are needed. For the column names are not hard-coded into PKNCA. They can be any column name in your data set, and the columns would be provided to PKNCA conc, as we talked about a few minutes ago, PKNCA dose, where you would give the dosing data and the columns of interest for the dosing information. And then, for the concentration data, you need to give the concentration itself, the time, so how many minutes, hours, days post-dose was the result measured, groups, and groups are something we'll discuss in more detail in a few minutes. In general, you can think of groups as at least the subject information, and but also treatment, often treatment information, sometimes the study name. You can give the exclusions, saying, here's a column that indicates the data that I want to exclude from the data set. And that would be, there are two different types of exclusions that we'll touch on briefly later. One is excluding a concentration measurement from all time point, from all calculations, and another is to exclude it from just the concentration, just the half-life. There's a question in the chat asking, are there any restrictions on the column names? There should not be any restrictions as long as it is usable within R. It has not necessarily been extensively tested with international character sets in the column names, but in principle, it should work as long as R can interpret it as a column name. The dose, for the dose, it's very similar. You give the dose amount, so how many milligrams or milligrams per kilogram, whatever units are appropriate for the dose. The time, which again needs to be on the same time scale as the concentration measurements. The groups, which we'll get into in a little bit more detail in a few minutes. In general, they're the same as the groups for the concentration data, where you would usually at least have the subject identified, often also the treatment and perhaps fed status or other components that you want to carry through in the non-compartmental analysis calculation. You can also indicate the route of administration. Was it intravascular or extravascular? The rate or duration of an infusion, and similarly, if there are any doses that should be excluded, then you would indicate that in the in additional columns. The other function that I mentioned a few minutes ago was the PKNCA data function. What it does is it combines the concentration and dose data together and allows you to, and also uses that to determine either for you or to help you understand what it'll either determine for you what parameters to calculate based on heuristics of what you likely want, given the concentration and dose data you have, or you can ask for specific calculations. And so for that, what I mean is that that you can say, I want Cmax for this time for this subject, or for Cmax for this treatment in this time interval, versus, and maybe I want AUC interval for one group and AUC infinity for another group. There are no restrictions on the complexity of the differences in what you want to calculate between the different groups of subjects. One of the concepts that PKNCA is built under is that the goal is to be able to calculate complex studies in a single run. So for instance, you can have a study that has single dose and multiple dose. Maybe it has IV dosing and subcutaneous dosing, and maybe oral dosing as well, with maybe more than one drug administered for a drug interaction study. And you can do all of that in one PKNCA run. That's up to you. You can, if you find that is too challenging to set up because you have to think about all of the different parts separately, you can definitely run more than one time through all of these steps for every different analyte that you have, or every different study design that you have. Totally your option, but PKNCA does have the ability to do everything at once. Two questions that came up from the chat are about units. I'm not planning to go into units in detail during this presentation. However, there are some PKNCA is able to manage units and do unit conversions for you. There are no restrictions on the units that you can provide, and if you provide units that aren't clearly convertible, for instance, you have mass and you want molar units in your output, then you can provide the conversion factors. There is a vignette on the PKNCA website about how to use units. And for the dose question, the question is, do you have to have the column named dose, time, and group, or is it just defined from the data? We'll go into that in a little bit more detail later, but it is, you provide the information as the columns to use, and you'll see that in a few minutes. So here's some more information on what I was talking about, how to have all of the how to have all of the information and provide it to PKNCA. If you have, for instance, a data set where there's 2 treatments administered to 2 subjects, you can, and one of the columns in your data set is called treatment, and another column is called subject, then you would indicate all of the other parts of your data set and then say, give the pipe symbol treatment plus subject. And if this is confusing, then bear with me and you'll see a more worked out example a few slides later. PKNCA will consider the groups in order. So it groups, if you have multiple groups, for instance, maybe you're analyzing multiple studies where you have multiple treatments and you have multiple subjects in each of those studies and treatments, then you can give study plus treatment plus subject. And the default is that the subject should be the last grouping because that's the innermost measurement that you want to have. There is another way that you can indicate typically analytes, like if you have a parent of the drug and a metabolite, then you can use a slash for that. That's not a typical use case where you would use it in that way, but it's definitely possible. So here's an example data set, very simplified, as you can see, just 2 subjects with those 2 treatments. This is what I was describing on the previous slide. You can imagine these columns as rows in a CSV, Excel, SAS file, any type of tabular data file. And you have the subject number 1 or 2. It doesn't care if subjects are numbers or letters, or it can be anything that is different from each other. It just can't be missing. The treatment, it can be named anything. In here, it's named treatment. And you have treatment A and treatment B for subject 1, and then treatment A and B for subject 2. And they have their various concentrations measured at time 0, 2, and 8 hours. In a typical example, you'll have more time measurements, but I'm trying to fit it on the slide here. And then the dosing data will often look similar. Maybe in this case, you have treatment A and B are 2 different formulations of the same drug, and they have doses of 10 milligrams in treatments A and B. And so you would have both treatments show up for both subjects with the dose for both subjects. It can be simpler than this, where perhaps since everyone in treatment A and B is getting 10 milligrams at time 0, you could actually just give the treatment A and B without indicating subject, because PKNCA will then infer, because you didn't tell it about the subject, that every subject in treatment A received 10 milligrams, for instance. And just so people are aware, I like the questions that are flowing through the chat. I am going to keep an eye on them and answer them a little bit more together in a few minutes. So thank you, keep them coming, but I'll get to them in a few minutes. And then the next concept in terms of data sets coming in is you need to have intervals, and intervals are the concept of when do you want to do what time frame do you want to do the calculation on. As an example, in this here, in the previous data set, we had concentrations going from time 0 to time 8 hours. And so our interval has a start and an end of 0 to 8 hours. It's saying true for Cmax, I do want Cmax, true for Tmax, I do want Tmax, and true for AUC last, I do want AUC last. All of the names, so start and end are required names for the data set, for the interval data. And the other names for the column names for the data are the different parameters. There's a list of parameters that you can see within the PKNCA vignettes that go through all of the different parameters that exist within PKNCA and what they are and how to use them for calculation. In general, you would give an interval data frame saying the start and end time, possibly different grouping information, such as if you wanted treatment A to have the interval from time 0 to 8, And treatment B, maybe you wanted the interval from time 0 to 6 hours. You can give the treatment information as an additional column here and then get different information by treatment. The groups are not required if you want the same calculations done for every individual in every group. This is a much longer, a lot of code, and the intent here is that you could follow along with this in your on your own computer, not necessarily right now, but on your own time perhaps, where you can run and get the concentration data from the theophylline data set that's included with R, pull out just subject number 1, and that's now our dconc variable, so that's our concentration variable. The naming of the concentration data does not matter. And in that data frame, we're saying we're first creating our, sorry, let me step one step back. All of these libraries are used for various aspects of loading the data and managing the data. If you have your data loaded and you just need to run PKNCA, all that's required is library PKNCA. So jumping back forward, once you have your concentration data set, which can have more than one subject, but for this example, I just filtered it to one subject. I now send it to the PKNCA conc function, where I tell it the concentration data, which is on the left-hand side of the formula here. It comes from a column named conc. The time comes from a column named time, and the data is named dconc. I'm setting the intervals so that they start at time 0, they end at time 24. I would like to have Cmax, Tmax, AUC last, and then earlier we talked about AUC int. There are many different variants on many of these parameters. This is the area under the curve for an interval, where if it needs to extrapolate using AUC infinity, it will do so using the AUC infinity method, so going beyond the last concentration, using the observed concentration at the time of last concentration above the limit of quantification. A whole lot is packed into that statement. And all of this, again, is documented on the PKNCA website, where it describes all of the parameters that are available. After that, you'll notice that you'll see that I'm using the PKNCA data function, and I'm not giving it the dosing information. Dosing information is only required if you need to calculate the parameters that require dose. So for instance, if you need the clearance, which requires dose in the calculation, then you have to give dosing information. If you are not looking for parameters that require dose, you don't have to give the dosing information. And then next, the result is calculated. I used suppress messages just because there's a message that pops up saying you didn't give dose. And for the purposes of this slide, that was not an important detail. And then use PKNCA for of that data object that says, here's my concentration data, and here are the intervals that I want to calculate it over. At the end, you can run a summary on that, and it will give you a tabular summary of how to of what your NCA results are. I'm going to take a brief pause to go through some of the questions in the chat window. One question is, what about if each individual has doses at different times? In that case, then you can give the individual level, you can give all of the dosing information for each individual, similar to what was shown here. Just give the actual time of dosing for each individual, and and PKNCA will work with the actual times. Someone else is indicating that in the past they've had issues when they didn't have concentrations at time 0, and is there a way to work around it? I'm not planning on covering that in this session, but on the PKNCA website, there's a discussion on imputation methods where you can, it sounds like for your example, use PKNCA to tell PKNCA my concentration at time 0 is 0, and so automatically impute that if it's missing. When you do that, there are two ways that you can do it. One way you can do it is you can say if it's missing, then put 0 in there. But if it's not missing, maybe there is a non-zero concentration at time 0, then it wouldn't modify it. There's another way where it will force it to be 0. All of this is documented in the vignette about imputation. The next question is, what about time in case of multiple repeated doses? In that case, you can just say similar to here, you could have multiple rows for each of, you would have multiple rows for each of the different doses that the subject receives. And so subject 1 in treatment A received doses at time 0, 24, 48, and 72 hours. And they can be the same or different doses. It doesn't all have to be 10, in this example, 10 milligrams. And you can just give all of those different time points in as different rows, where each dose that was received is a different row here. You can, if you have the same dose administered in each of the time intervals, you actually don't even have to give the time point. You can just say that all of treatment A uses a dose of 10 milligrams. And the way to say that, which I'll show in a few minutes, is you give the dose amount, but before, sorry, I'm trying to find the right slide. The equivalent of the PKNCA conc example here, where you would give the dose, you would just say the dose tilde and a period, and that period indicates whenever you need a dose, whatever time point, use the dose that's in the dose column. For that, you would just have one dose per group, meaning if it's all one treatment or all one time point, then you can have the same dose administered at each of those. And in general, PKNCA, as I think I mentioned earlier, can handle multiple dosing and combined multiple and single dosing in a single PKNCA run.
So Bill, if I may.
Yes.
So for all the participants, this is just the preliminary starting point, and you will actually have access to example data sets as well as information that Bill is talking about in terms of you will have access to the slide deck, the recording of today's presentation, and to also facilitate and deepen your understanding here, we have split all of you into smaller groups. And we would strongly encourage that your groups meet between now and November 1st. And all the pieces that Bill is covering today, when you're working on the assignment hands-on, you will be able to really experience it. And if you're having questions while you're working through it, please reach out to your coordinators. We have assigned 2 coordinators for each group. So you can get that support that you would need so you can understand and like really get to do this work. And I can see that because there is time between now and November 1st. So in this period of time, you will be able to capture all that is being discussed here. And on November 1st, when we meet, we will actually go through the homework assignment in detail and go over the various questions or issues that people have faced. So rest assured, you will be an expert to do NCA analysis in R, and that is our promise to you. I hope that helps.
Yes, thank you. Yeah, so then I see some more questions where they're a little bit more specific to data sets, I will I'll leave some of those questions to either the end, or we can address them offline after the discussion. I do appreciate all the questions that are coming in. I like the engagement, and I really appreciate it, so please do keep them coming. But I do also want to make sure that I'm able to get through the planned material, and so I'll try and balance those going forward.
Yeah, and just to continue the same, we are capturing all the questions that are coming in the chat. And Bill may not be able to address all of them in the workshop live right now. However, we will be creating a Google Doc in which we will populate all these questions and Bill's answers to those questions as well. And you will have access to the answers via the Google Drive.
Thank you. All right, so the next step, I'm going to step into the functions that are used for PKNCA and how they fit together. Going into a little bit, we touched on some of the basics in the previous few minutes. Now I'm going to go into a little bit more detail on each of those different functions, what they do and how you use them. So you've seen these 4 functions in some of the prior examples. What goes into them, what do you need, and how do you use them? PKNCA conc, PKNCA dose, PKNCA data, and PK.NCA are the 4 primary functions that you're going to touch within the PKNCA library. The PKNCA conc object takes in your concentration and time data, takes in the groups that is usually given. Often you'll have multiple subjects in the data set, and it lets you choose the time points to exclude from all calculations, or to include or exclude for the half-life. You can either choose specific time points that you want the half-life to be calculated based on, or you can say use the typical automated methods, but exclude these points that I don't want to be used for half-life. PKNCA dose object, it is optional, but it is required for any calculation such as clearance that you would want to that require dose for the information. It takes either the dose amount or the dose time or both. Most typically, people either don't give it and give the intervals themselves, or give both the dose amount and time. If you just give the dose amount, then it's assumed that any interval where there's a calculation performed, any interval of time where a calculation is performed, that the dose is administered once during that interval. If you just give the times, then what that allows PKNCA to do is, when it's trying to help determine the automatic intervals to use based on your concentration data and your dosing times, then it will look for times when you have dense PK sampling, so more than just troughs at the beginning and end, and make a best guess of the parameters that you want to be calculated during that interval. The data, as I indicated before, it combines the PKNCA concentration data set and the PKNCA dose object, optionally and usually the intervals, and then into a PKNCA data object. This is where you would group everything together. The intervals that you would be adding to the PKNCA data object tell all of the parameters that you may want to calculate. So for example, if you want to calculate clearance, then you would put, similar to what we were seeing on the previous slides, where you had the interval, had the Cmax, Tmax, and AUC last, you can say also calculate the clearance, and you can tell it how you want to calculate the clearance by clearance based on AUC last is CL.last. You can find the list of all of those on the parameters vignette on the PKNCA website. Then finally, the PK.NCA function is where the calculations are actually performed. That's where it will actually calculate the parameters, and it takes in the PKNCA data object that you generated using the concentration, dose, and interval data previously. this is the typical order this is pretty much the order that you do the calculation, the use of the functions, and almost every PKNCA run is these steps in this order. What does that simple calculation look like? And for that, and it is very similar to what we were looking at a few minutes ago. You have your concentration data, concentration time. You have your dose data. In this case, the dose is within the same data set, so I'm filtering just to time 0 from that concentration data set. And the column is named dose, and the other column is named time. Again, the column names can be anything. These are just whatever you have as the column name in your data set, you give at the beginning of the function of the call to PKNCA conc or PKNCA dose. You combine PKNCA conc and dose into PKNCA data, and those and then that gives you a data object that has all of that information that we were talking about before: concentration, dose, and the time intervals for calculation. Provide that to the PK.NCA function, and that will give you a result. Once you have the result, you can look at your data. You can this would be just looking at the data in the normal way that you would look at any data set in R. And for the data set that we just created on the previous slide, it would look like this. Just the first 2 rows have the subject number and a column named subject, the weight, the body weight, dose, time, and concentration. Because you're not telling PKNCA anything about the body weight or the dose as it's going into the PKNCA conc, because you're only telling it about the concentration and time columns, then the other columns are effectively ignored. You can have as much other information as in your data set, but it does not affect the PKNCA calculation. For your dosing data, it again looks, when looking at just the dosing, the 1 row in that data set, you have the same columns, but now we're only telling it about the dose column and the time column. And it comes from the dose data set, and that is put together for your dose object. When you calculate the results themselves, you then take that data object and you put it into, you do the calculation, and you have your result here. You can then use this result to either, you can then have this result either give you all of the results, as we'll look at in a few minutes, or a summary using the average or median range, whatever summary statistic is appropriate for your calculation. You can also control those summary statistics. For that, to get the overall summary, you would use the summary function, which is used throughout many different methods in R across many different things. You can summarize lots of different parts of R, and that will summarize the parameters that you specifically requested. For example, if you request AUC infinity using the observed C last, then what it will return to you with the summary is just the AUC infinity, if that's the only thing you request when you're using the summary function. When you use as data frame, there are many other calculations that have to be done behind the scenes to get to AUC last. You have to calculate AUC infinity. You have to calculate the Tmax, Cmax, Tmax, half-life, AUC last, and then that goes to AUC infinity. So when you use as data frame, you'll see a lot more parameters show up than just the ones you requested, because all of those were required to be calculated along the way. The data frame itself, when you run summary, it will also give you a summary of the different ways that your summary statistics are calculated. The default for most of the parameters other than time point related parameters is the geometric mean and geometric CV. For the Tmax, it's median and range. But if you prefer a different parameter, there are ways that you can set that up within PK. You can tell it use a different summary statistic, and it will use that different summary statistic. And then whatever summary statistics you're using are shown in the caption so that there's never any confusion about what exactly you're looking at in these summaries. And a hint for reporting is that the Pander library has a Pander function that if you give that summary of the PKNCA summary, then it will put the caption as the caption to a table in a report for you automatically. When you run that summary, here's what the summary looks like. It says, so I ran Pander on the summary of my result, and it has the different grouping information, the start and end time of each calculation, the parameters that were calculated for each of them, and this is that automatic caption where it says AUC last, Cmax, AUC infinity are all geometric mean and geometric coefficient of variation. Tmax is the median and range, and half-life is the arithmetic mean and standard deviation. I didn't type this in when I generated this, when I generated the slides for this training. This automatically came because of the way PKNCA works. And here, because AUC, if you run as data frame on these results, you can see the individual calculations that were performed. There's another column out here called exclude. This gives information about parameters that may need to be excluded for various reasons. For instance, if you aren't, the example I gave earlier, if you're not able to calculate the half-life because you have too few points above the limit of quantification, then it will give that information. It will say only 2 points were above the limit of quantification after Tmax. Therefore, we couldn't calculate half-life. 3 points were required. Some text very similar to that. The data sets themselves are the 3 data sets we've been talking about, and it only uses these 3 data sets. There's no more data that you have to give it. There's no more, all of the information on your data is contained within these 3, the concentration time, dose time, and the intervals. The complexity of the data sets themselves can be simpler than all data for all individuals if that is easier for you to work with. The example that I often use, especially when I'm in the middle of a dose escalation study, is maybe I have the concentration time data coming in directly from the lab, but I don't have the dosing data coming in directly from the electronic data capture. Then I may use the PKNCA, then I may tell it that everyone in treatment A got 10 milligrams at time 0. And then PKNCA can work with that without having to have a row for dosing for each different subject. You can just have a row for dosing for the treatment. Intervals are one of the concepts that often is a little bit more complicated for individuals who are new to PKNCA to understand. So I've drawn the example here on 1 grouping level and then 3 intervals for that grouping, where I'm not planning to read all the text on the right. It gives a description of what we're going to look at, but I'm going to try and describe it so that it's a little bit easier to understand. In this example, there is 1 subject, so maybe 1 subject in 1 treatment, who receives 3 different doses every 8 hours. So you have a dose at time 0, 8, and 16. And I want to calculate the parameters for each of those doses separately. In my data set, I would give the grouping level as a subject with a dose. So, as a subject, so subject 1, and that would include all of these time points. For the intervals, I would indicate that the start and end time are 0 to 8, and then the start time for the second interval is 8, and the end time for the second interval is 16, and the start time for the third interval is 16, the end time for the third interval is 24. So it would be 3 different rows in the intervals data set. And maybe I want Cmax in each of them, so in each of those rows I would set Cmax to true. maybe I want AUC infinity in each of them, and then I can give, AUC last in each of them, or AUC interval in each of them, and I can set that to true for each of those rows as well. But the way that the data set is set up, there are three different rows of intervals that all apply to one grouping level, one subject. Part of the reason for this is sometimes time points need to be shared in two different groups. Here you can see the point at 8 hours. It applies to being the end of that first interval and the beginning of that second interval, indicated by the arrow of the green and red colors pointing at the same time point. The same is true at the 16-hour time point, that measurement applies to both the second and third interval. If you separate out your data set into where you pull it out as three different intervals, then you have to do more work to put that time point at 8 hours. You'd have to duplicate the row to be in both of those different intervals. If you separate it out as, for instance, the count of the doses, then if this is just before the second dose, it may go into the second interval, but it wouldn't be available for the third. It may go into the first interval, but it may not be available to the second. Some of the questions that are important in setting up your data are, what are the data management requirements? Time cannot be missing. If you have a missing time, then there's no information on when a measurement was taken, and so PKNCA can't use that measurement. You either need to remove the measurement from your data set or figure out what the actual time it was collected, the concentration was collected on. Concentrations below the limit of quantification must be set to 0 and not NA. It's not missing information. Missing is when the sample is not collected, but and so it does need to be set to 0. If you set a concentration to missing PKNCA with setting it to NA, then PKNCA omits it from calculation because it is interpreted as a sample that was never collected or never analyzed. Time 0 is required for AUC calculations. As I mentioned earlier, to start an AUC, you have to know if you're starting at you have to know if you're starting at 0, or maybe if it's multiple dosing, you're starting above 0. PKNCA has to know where to start that calculation, and so you need time 0. There are many imputation methods built into PKNCA. You can see those on the imputation vignette within the PKNCA website. For the actual time calculations, the imputation of the beginning of the interval is usually needed. So what that means that for most actual time calculations, the time 0 concentration measurement is taken before that first measurement. And so there are, again, the imputation methods that can we haven't discussed this imputation method, but it can shift the prior concentration over to time 0. So if you have a measurement at minus 30 minutes, then it can move that concentration over to 0 for you. But you do need something at the time 0 time point, either by giving it in your data set or by using one of the imputation methods that does it for you. And then in your PK data set, you do need concentration data, dose data, concentration data, time data, and then the various groups. And like I said, the groups are typically study, treatment arm, or subject. Sometimes it's also analyte or formulation or period, or can be almost anything else. But those three, study, treatment arm, and subject, are the most common ones. Concentration data has to be numeric. It can't be text. I would say that probably 3 or 4 times a year, I'll get a question of where there's an issue with the concentration data, and PKNCA is giving an error saying concentration data has to be numeric because it doesn't do a text to numeric conversion for you. You have to do that conversion beforehand. The time data has to be numeric and not missing, as I just described. And groups can be anything that's set up at the and they're set up at the level of the individual or more. for example, here's a group of killer whales. It's a pod of killer whales. So how do you set up your dosing data? And this goes into some of the complexities that I was mentioning earlier about about if you have missing information, either the missing time information or the missing dose information. So the full data set would be giving the dose amount in milligrams per kilogram. It could be a radiation dose, whatever the appropriate dose is for your study. The time when the measurement is administered. Act arm, here's an example of the actual arm in a study, and unique subject identifier. Part of this is also to show that the column names, again, can be anything that's in your data set. There's nothing pre-specified, and it just needs to, all of those need to come from the D-dose data frame or tibble. If the dose amount has to be numeric, or it can be omitted. So in this case, if you give the formula instead of having dose tilde time here, then you just give it tilde time, then the dose amount is missing. You wouldn't be able to do any calculations like clearance, but PKNCA can help you determine what intervals to use for your data set. And then the actual arm and the subject identifier. As I indicated earlier, you can also have the time missing, in which case you would give dose tilde period. The period is necessary just to make it work within the way that R requires formulas to work. But this means that the time is missing. And then the same dose level would be assigned anytime you have the group of a subject in an arm in your data set. And groups can be anything that is, but it has to have the same groups or fewer groups than your concentration data. Because if you had more groups in your dosing data, then there would be some additional information. There is something missing about how to assign the doses to your concentration information. I indicated this earlier that one of the things that I often do when I'm working on first in human studies or other early phase studies where you may need to do interim evaluations of the PK is I may give my dosing data set where I have a dose amount, I have the arm information, and that's all. Those are the only two columns that are in my data set. And PKNCA will then be able to calculate all of the parameters, such as clearance, from there. Within the calculation of intervals, every interval has to have a start and an end time. You have to tell it what time points are required for doing the calculation and what the beginning and end are. The start always has to be a number. It can be negative. PKNCA doesn't care if the numbers are positive or negative. It will start just at whatever time you indicate it should start at. The end just has to be after the start time, and it can be infinity, which would be used, which is often used in single dose studies to capture whatever is present in the concentration data set through time infinity. You can give any amount of grouping information you want. So, for instance, if you have a treatment level grouping information, then you can just give the treatment arm. If you have different time points for different subjects, as often happens in oncology studies, but can happen in any study, then you can give the information on what time points to use for each individual subject in each grouping, and PKNCA will work with that. When you want to calculate a parameter, you simply set that value, the column name, to true. And if you don't want to calculate it, set that column value to false, the value in that cell to false. So you'd go to the row from 0 to infinity, and I want to calculate Cmax, set it to true. I may not want to calculate the AUC tau, and so I wouldn't, or AUC interval, and so I would set that to false in that time frame. And as I indicated earlier, there's on the PKNCA website, there's a vignette on all of the parameters that can be used for calculation. You only have to specify the parameters you want, not all parameters. Different NCA software handles this differently, but PKNCA will calculate everything you ask for and everything that's needed to make those calculations. So with the AUC infinity example I gave earlier, the AUC last is a required parameter to calculate AUC infinity, and so it will calculate that behind the scenes even if you don't ask for it. You don't have to say calculate AUC last because I know that I need that to calculate AUC infinity. So here's a typical example of the intervals data frame where you have the start and end time. This would be an example that I often use for 24-hour for dosing that's intended to be once a day. So the start and end time are 0 and 24. I want AUC last during that first 0 to 24 time period. And then I want AUC for the time from the dose all the way to infinity. I don't want AUC last in this case, but I do want Cmax, Tmax, half-life, and AUC infinity calculated with C last observed. And this is very similar to what we were looking at earlier. The difference here for this example is we're starting with a Theophylline data set, and I'm pulling it into two different groups. Actually, I'm going to pause for a second and answer a few of the questions that are in the chat. One of the questions is PKNCA able to address covariates? PKNCA does not handle subsequent analyses beyond the non-compartmental analysis calculations. Doing that, there are many different ways that you can do it and many different ways that it can be handled in R. So the typical way that when I need to, as an example, estimate the area under the curve, the correlation between the area under the curve and dose, and body weight, I'll do that regression using other tools. The reason PKNCA doesn't do that and doesn't do some other similar things that are analyses beyond non-compartmental analysis is because both you're working in R, which has many different statistical tools available, and the specifics of how to do it that are more extensive than what PKNCA would ever have built in directly, and they're just available in R anyway. The question on if you have rows that are not unique per group and time, I'm going to assume that you're not talking about sparse NCA dataset. PKNCA does handle sparse calculations, but that's not the focus of today's discussion. If there are rows that are not unique, then PKNCA, so let's say you have 2 measurements for subject 1 at time 1 hour, then PKNCA will give you an error and tell you, look at row 5 of your data set. There is duplicate information there. Please fix it, because no NCA method can directly use multiple measurements per group for calculations that aren't for sparse NCA parameters. The question of can PKNCA calculate urine or drug effect parameters? Yes, PKNCA does have the ability to calculate urine parameters. For drug effect parameters, that's really the same as normal NCA parameters, just you need to, instead of putting in the concentration, you would put in the measurement of activity or inhibition, and PKNCA can work with that. If you have measurements that become negative, then you will have to tell PKNCA that that's not an error, because PKNCA does have a few error checking routines. And for instance, since its main purpose is concentration measurements, and you can't have negative concentrations, PKNCA does give you an error in that scenario. An error and tell you, if this is intentional, here's how to turn off this error. Next question is, what happens if a sample concentration is actually missing? It's fine if a sample is actually missing, provided as this is relating to the concept that I said earlier, BLQ should be set to 0, not NA. But if you set a value to NA, so missing, not applicable, then PKNCA simply ignores that time point. It is missing. It was never taken. It's not an error within PKNCA. PKNCA will just find that that point is missing and ignore it. And then the next question is, does the dose tilde time in the function mean selecting the columns from dose to time? Will the other columns be selected? This is not the tidyverse style where you would use dose colon time for selection of columns. This is a formula notation within R where, so it is, the tilde does not mean and everything between. It means the measurement of dose occurs at the tilde, a time point, for a grouping, the vertical bar, everything it's grouped by. Okay, jumping back to the preparing the data for calculations. In this example, I'm taking the theophylline data set and grouping the individuals into high and low dose. If someone is less than or equal to the median dose, then they're assigned to the low dose group. And if they're not less than the median dose, then they're assigned to the high dose group. This is arbitrary based on this data set. In a typical example, you would have that treatment information in your source data set. For the dose information, I'm simply pulling out the treatment, subject, and dose columns, and then collapsing it down using the unique function to make it so there's only one row per individual, and setting the dose time to 0. So to do the calculation without dosing, you set up your PKNCA concentration data set where you're giving it the concentration till the time to tell it the concentration measurement time point for each treatment. So now that will be the high and low dose groups that we set up on the previous slide for each subject, and it's coming from the dconc data set. You'll notice that there's some foreshadowing about what's about to happen because I wrapped this in the try function because that's an error. Why is that an error? What happened is we didn't give any intervals. And so if you're only giving, we didn't give any intervals to the PKNCA data object. And so PKNCA has no idea what it needs to calculate. If you give the dosing information, then it can figure that out automatically for you. But in this case, it doesn't know what to do, and so it tells you. If data.dose is not given, the intervals must be given. It puts it out in front of you saying, this is the error that PKNCA sees, and so please give the intervals intervals data frame. So now if we set up the intervals, then it will actually run. D intervals is a data frame where start is 0, end is infinity. I would like to calculate Cmax, Tmax, half-life, and AUC infinity observed. In the PKNCA data object, I say, here is my concentration data, and here are the interval, which comes from here. Here are my intervals, which come from here. So now I have my data, and now I can run PKNCA on it, and just to do everything all at once, which you typically wouldn't do. I'm also going to summarize it. And for the run of the pk.nca function, it gives a warning saying no dose information was provided, so calculations requiring dose, such as clearance, will return NA, missing. And then it gives the table of information here that is equivalent to what we saw before. And because this is showing up as text as opposed to being printed out using nitprint or pander, then the caption just shows up as text below the bottom. Now, the other way to do it is if you give the dosing information, then PKNCA will use that dosing information to automatically calculate the intervals. So here we have the same concentration data set up. We're now giving the dosing information, the same as the way we had talked about before, where we have the dose and the dose time, treatment and subject. One thing to be aware of is that the column names, as we've talked about several times before, are not specific or not built in and don't have a requirement. So for most of the examples up to this point, we had an example where it was time, but now it's dose time. The reason for that, I'm going to jump back a few slides, is because when I was creating the dosing data, I named the dose time as dose_time. And and for the parts that are specific to concentration or dosing, so the concentration measurement and the time measurement, PKNCA does not care whether they match between the concentration and dosing data. PKNCA does care that the dosing grouping levels are either the same or less specific than the concentration data. Now, when we send both concentration and dose information to PKNCA data, it doesn't require the intervals because it will automatically look at your data sets and determine what the likely intervals you want calculated are. In this example, and you can modify that if you want, because you can go in to the dollar interval, which is where the intervals are stored within that data object, and say for all rows, I want AUC infinity observed to be set to true. And now for time 0 to 24, we have all of the parameters that we were looking at calculated previously. AUC last on 0 to 24, not Cmax, Tmax, or half-life, or AUC infinity observed. And then we have AUC interval infinity observed calculated on the 0 to 24 time intervals. And you can see that that is, as it should be, less than the AUC than when calculated through time infinity, because there are a few time points that are beyond the 24-hour time point. One of the last topics we're going to discuss is the variations on different AUCs. PKNCA has a lot of different AUCs that are available, and that's because there are a lot of different ways you can calculate AUC. These considerations mainly apply to actual time data. Most of the time, nominal time data has a measurement at each of the ending times where you want the nominal time to be calculated. And so if you have an interval that starts at time 0 and ends at time 24, and you can see here the points that are measured are the black circles, you can see that there's one time point that is measured just beyond the 24-hour time point. If you have AUC last, the blue shaded region, it's calculated only using the time points that are within the interval. It doesn't look beyond the interval to calculate anything. And so it calculates from 0 to 12 hours. For most of the time, that's not the calculation you're looking for, if you are looking at single dose or multiple dose data. If you have AUC int, that does the extrapolation that I was talking about earlier, or interpolation. In this case, it interpolates, and it's a little bit hard to see, but it interpolates up to the 24-hour time point, but it does not interpolate to this time point that's slightly beyond 24 hours. And so it is all of the blue and this green region is the AUC int. And then AUC infinity uses AUC last and then extrapolates to infinity. So the other thing you will notice here is it uses the blue region, and then because the half-life is calculated from these time points up here, it doesn't actually go through this this time point that's just after 24 hours. That's outside of the interval. It's not considered. And so you usually, if you want AUC infinity, you do want the end of the interval to be infinity, or at least be aware that it's including all of the time points that you intend for it to include. All right, so that's the last major topic where we'll be discussing things in any real level of detail. There is one of the important things for regulated work is to be able to validate your to be able to validate your installation of the software and make sure that it's working the way that it's intended. What you can see, there's a link here to the PKNCA validation vignette. If you go there, you can see instructions on how to run PKNCA so that you can generate a validation document that indicates all of the tests that are run for PKNCA and whether they passed or failed. If you ever have a test fail in the validation, please contact me. That is something that we would need to look into. I've never seen it happen to date. And so now I'm going to briefly indicate what will be covered in the hands-on workshop. We're not going to go through the work itself in detail, as Arunya mentioned earlier. That's going to be handled during the time between now and the next session. So the first, as you may recall, seeing the ORCA information, there's some data that has been extracted from the PK study of amikacin in a killer whale pod, and a killer whale and a beluga whale. This is the DOI to the reference where it came from. And the goal of the first hands-on project will be within the hands-on 1 whale PK directory, load the data from the CSV file provided for concentration and dose, and then use that to calculate the AUC last, Cmax, and Tmax for that data. The second activity is to calculate single and multiple dose data. This is intended to look like what you would often see in a multiple dose study. So calculate day 1 and the last day, day 6, where we would want to look at AUC interval, Cmax, and Tmax on both days 1 and 6, and then also look at half-life on day 6. And that is all of the information that I had prepared. I see that there's one more question in the chat asking, is there a function to define the best fit regression as with win on lin? PKNCA uses the same methodology when using automatic regression to calculate the best fit, minimizing the adjusted R squared with at least 3 point concentration measurements. You would then have the ability to also do exclusions based on your business rules of typical exclusions are requiring a minimum span ratio of approximately 2 and or requiring an AUC percent extrapolated to be less than 20 or 25%. So with that covers the material intended for this discussion. As you can see, if you've been paying attention to the slide numbers, there was no intent to go beyond the 46 slides here for this presentation, but there are more backup materials if you want to go into more depth in many of these topics. And in general, again, I'll point you to the PKNCA website, which has many vignettes that can take you through. And for the next few weeks, there's also your groups to work within for the training sessions.
Thank you, Bill. Thank you for actually leading today's workshop. And as I was mentioning earlier in the call, so please consider this as we are actually teaching you how to ride a bike. So this is just concepts that Bill has shared with you. You will only be able to ride the bike when you get on the bike. So, and that is for you to go ahead, do the exercises hands-on, and that's when you will actually come across real-world problems, including simple thing as R installation. We have shared information with you on how to do the R installation if you're new to R. Please reach out to us if you're having issues with the installation. Again, we will put the email address in the chat you can reach out to ppc@pharmaproconsulting.com, and we will ensure that your email reaches the right individual to help you answer questions that you have. For some of you, you may not be familiar with R, or you would like to have a fresh overview of R. We have created a user-friendly, easy to understand, bite-sized pieces training material, which is available in Slack. You may have received, or you should have received, the email with the details of how to join that Slack. That is Project Dontabhaktuni University Slack. So you will be able to get there and go through the step-by-step. I think we have made it very easy to understand. However, if you're getting stuck or if you have questions, please reach out. So you have two options for you to refresh your R. One is to use the Slack, and it is, in fact, easy because you have videos and then you have access to Google Colab. So even if you don't have R installed on your computer, you can go through the Google Colab, wherein you'll be able to tweak with the code and you'll be able to run that NCA analysis, the R necessary piece of work that you need to do. And while you're going through that, you will also be able to, and by the way, we are at 11:31 right now. My request is, if you're able to stay for another 10-15 minutes, you will be able to connect with your team members and go over on when you can meet. So in the interest of time, I'm actually just going to close today's meeting by acknowledging our sponsors. So again, a workshop of this size would not be possible without the support. First of all, I acknowledge Bill for taking the time, running today's workshop, and be here to address your questions. Again, as I had mentioned earlier in the call, that today's sponsors are Gilead Life Sciences, PharmaPro Consulting, and Human Predictions. And if you have not realized it already, Bill is the founder and CEO of Human Predictions, and we will give you his website information and also his LinkedIn. Please feel free to reach out and connect with him, and if there are opportunities that he can support you with. Another sponsor of today's workshop is PharmaPro Consulting, and so PharmaPro Consulting is a company that supports pharmaceutical companies with their drug development needs, and we support data management, PKPD modeling, strategic advice, exposure response analysis, or anything in terms of pharmacometrics, study design, regulatory affairs, and CMC regulatory. These are some of the clients we have supported, and we are proud to share that we are certified as a women-owned and a minority women-owned organization. Again, as I was saying earlier, Project Dontabhaktuni is made possible because of unwavering support and guidance from our board members and volunteers. A big shout out to Rajan, who's here with us, and without his help, this workshop would not have been possible. And few other board members are Partha Nandi, Bhaskar Gandavabi, who's the one who has created the Slack, our workshop that you are seeing. Somdeep Datta is also another important piece for creating that R workshop. And Major DVD Prasad Rao, who is our board member, who is also happens to be my father, and instrumental in making Project Dontabhaktuni happen. I also want to give a shout out and acknowledge our organizers who have been helping out. So Arun, Jayashri, Tejashri, and acknowledging ISSX India for their unwavering and continued support. So today's Zoom meeting invite comes from them. Thank you for making that possible. I also want to acknowledge our coordinators, people who have stepped up to be your group leaders. And as I mentioned, we have close to 300 registrants for today's workshop. So we have 20 teams. And now we will actually split you into your teams so you're able to connect and talk. What we have also done is connected the team via email. So you have the information of your coordinators as well as your team members. We would strongly encourage for you to meet outside of here, whatever works for you, whether it's WhatsApp, whether it's Zoom, or any other means. So please do work together, get the homework assignments done. And we have a prize for the team that will be submitting or doing 100% of the homework and submitting the homework by the 31st of October. And when we meet on November 1st, we will go over the homework assignment and address any questions that you have. And our objective is that you become proficient in conducting NCA analysis in R.